There are three ways that we can solve systems of equations. And again, this is just solving systems of equations is something you guys have already covered in Algebra 1, which may have been a year ago, might have been last year, whenever it might have been. This whole first unit is just a review. So the first thing we're going to cover is systems of equations, and there's three ways to solve a system of equations. You can solve it by graphing, substitution, or elimination. The only thing you guys have to remember is that when you're solving for a system of equations, when you actually find that solution, you have to write it as an ordered pair. So just remember that you want to write it with that x and y value inside the parentheses as an ordered pair. That's your solution to the system of equations, that place where they intersect. So let's do one example where we are trying to find a point of intersection, but we're not necessarily putting those two equations onto a graph right away. So if we're trying to just determine if a given ordered pair is a solution or not, the only thing you guys have to do is check. Say, okay, I know what my x value is. That's the first one, and I know what my y value is. So we're going to plug those into your equation, and we're going to verify that it does make that both of those equations true. So if we're checking, let's plug in 2, 2. So plug in 2 for x, so 3x minus 2y equals 2. So 3 times 2 is 6, minus 2 times 2 is 4. 6 minus 4 is 2, so that works. And then check the second equation. So we have x plus 2y equals 6. So 2 plus 2 times 2 equals 6. 2 plus 4 equals 6. 6 does equal 6. So that's good. So, yes, that first one, letter A, would be a solution to that system of equations. So now let's check B. Again, 0 is going to be your x. Negative 1 is going to be your y. So 3x minus 2y. 3 times 0 minus 2 times negative 1. Be careful with your negatives. Equals 2. So 3 times 0 is 0. Negative 2 times negative 1 is positive 2. 0 plus 2 is 2. Remember, you have to check both equations, not just one. Just because it works for one doesn't necessarily mean that that solution is going to work for both equations. It has to work for both. So let's try it in the second one. So x plus 2y equals 6. 0 plus 2 times negative 1 equals 6. 0, 2 times negative 1 is negative 2. So 0 minus 2. Negative 2 does not equal 6. So no, letter B, or solution B, is not a solution to our equation, or our systems of equations. So let's move on here and do example 2 and example 3, and then you guys can try some. So moving on. Alright, so graphing is pretty nice as long as our solution is a ordered pair with whole numbers, but in order for us to be able to graph an equation, we have to get it in that y equals mx plus b form. So we have to make sure that our equation is in y equals form. So both of these actually need to be rearranged. So starting with the first one, we have 2x minus 3y equals 1, and our second one, or our second equation, is x plus y equals 3. I'm just going to start with the second one because it's one step, real easy to get that y equals and get y by itself. You just have to subtract the x. Now, instead of making it 3 minus x, I'm going to make it negative x plus 3, just simply so we have it in that mx plus b form. So we can identify our slope a little easier, maybe. Now over here, if we're trying to get the y by itself, we need to subtract the 2x from both sides. And again, I'm not going to make it 1 minus 2x. I'm going to keep it negative 2x plus 1. So the last thing we have to do is divide by -3 because we're trying to get the y by itself. So what happens is you get -2 divided by -3, which is going to give you a positive 2/3 x. And it's a little messy, but a y-intercept of -1/3. So let's try to graph that line first, that first one, y equals 2/3 x minus 1/3. Okay, so don't mind me, I'm just sort of writing, I just sort of zoomed in here so we could graph it a little easier. So my y-intercept is -1/3, so I went down from the origin, -1/3. I'm going to go up 2/3, so up 1, 2 over 1, 2, 3. I'm going to try to draw that line as straight as possible. And now we need to plot our blue line, which was -x plus 3. So at +3. And we're going to go down 1 over 1, down 1 over 1, down 1 over 1. So that line should be pretty easy to draw. So now looking at this, we can sort of see that our point of intersection is right there at, it looks like 2, 1. So the last thing we have to do is check it. So plug in 2 for x and 1 for y. So the first equation is going to be 2 times 2 minus 3 times 1 equals 1. And the second one will be 2 plus 1 equals 3. So we have 4 minus 3. We get 1 equals 1. And 2 plus 1, we get 3 equals 3. So they do check out. So we checked it algebraically and graphically. So we just have to remember that if our equation isn't in y equals mx plus b form, we have to put it into y equals mx plus b form in order to graph it, if that's the way it's asking us to solve it. So let's do number 3 yet, and then you guys can try that last page. So for this problem, we have the two equations x minus y equals 4, and x minus y equals -4, and x plus y equals 2. So again, has to be in y equals, so let's just write both of them down here. X minus y equals -4, and x plus y equals 2. So subtract the x. Don't forget to bring down the negative with the y. And then because the y is negative, we have to divide everything by -1. So we get y equals x plus 4. Both of them become positive. And over here, the only thing we have to do is subtract our x. So we have y equals x plus 4, so y-intercept at +4. And remember that slope, even though you can't see it in front of the x, is 1 over 1. Again, hopefully, if you guys want to get rulers to make those lines nice and straight, I'm just doing the best I can here on my iPad. And then your second line is y equals negative x plus 2, so start at positive 2. And the slope is down 1 over 1. And your line, of course, should go through all of your dots, but it looks like our intersection point is right there at negative 1, positive 3. So then all we have to do is check it. So plug in negative 1 for x and 3 for y. So x minus y equals negative 4, negative 1 minus 3 equals negative 4, and negative 1 plus 3 equals 2. Negative 1 and negative 3 is negative 4, so that's good. And negative 1 plus 3 is 2. So we did graph it correctly, and our solution to the system is negative 1, positive 3, written as an ordered pair always. So, if you guys need help with number 4, we may do it together, but you can go ahead and try it on the calculator. And then you also need to try that last practice page with the 4 extra problems on it. So, go ahead, get started, and good luck.